Hello my dear friends, welcome to my YouTube channel ADC Maths. In this video, I am going to solve or find the general solution of this first order partial differential equation Pyz plus Qzx equal to x squared. So see that this is completed is mixed P, Q, X, Y, L, Z. So all put together the same. But when you see this looks like PP plus QQ is equal to R model. So this is known as the Lagranges linear equation model. Right, sir? So what about capital P here? So here capital P is a function of x, y, z. Yes, this y, z other than the small p. What about Q? Q is other than the small q, it is x, z, and R is the xy. Got it? So the very first step is to write the axillary equation. So to write the axillary equations are dx by capital P is equal to dy by capital Q is equal to dz by capital R. So dx by yz, dy by xz, and finally dz by xy. So this is my axillary equation star, superstar equation. This is the fractions. This is not the fractions, this is the ratios. See the dx, but here x is missing. Here y is missing, here z is missing. So my aim is to find two independent solutions from this superstar equation. I can apply this same method of grouping technique. So can I choose the first and the second ratios? If I choose the first and the second ratios of the given superstar equation, axillary equation, so what I am getting that dx by yz is equal to dy by xz. Please put it down. Dx dy. So please fix x and y. Other than the x and y, try to cancel the other variables. So I feel that z is common, so we cancel. Then I would like to separate or group the variables. So what can I do that? I can cross multiply the x to the next side. Similarly here, I can cross multiply this y to the next side. So this becomes x dx is equal to y dy. No, I think so. They are grouped now. Am I right, sir? X dx the left hand side, y dy. Now do the integration. I am getting that x squared by 2 is equal to y squared by 2. So I can assume that the constant is also a by 2. This is my convenience. The constant is maybe a or a by 2. So by this way we get x squared minus y squared is equal to, even you can take a squared, does not matter. So I can take simply a or a squared, whatever it is. So this is my first required solution, u in terms of x and y. Yeah, obviously what is z? Z is in terms of x and y. So here u is equal to x squared minus y squared is the one solution. So the similar way to pick the other two ratios, if possible, to get the second independent solution, namely v. So how to get that one? How to get that one? Let us try the other two possibilities from the given superstar equation, that is star equation. So can I choose the second and third ratios? Can I choose the second and third ratios of the superstar equation? So what is the second one? That is dy by xz, and third one is dz by xy. Once again, please keep in that mind, the numerator is dy, dz. So please keep the y and z alone. Other than the y and z, please kindly eliminate the others. So I think it is this time x get cancelled. This time x get cancelled. So what I am getting that dy by z is equal to dz by y. So once again grouping the technique. So let's cross multiply this term. I am getting it is y dy is equal to z dz. So y dy is equal to z dz. So now they are grouped. So go for the integration. I am getting that y squared by 2 is equal to z squared by 2 plus some constant b by 2. So what I am getting that? I am getting that the y squared minus z squared equal to some b. So this is my v. So once we have found the u and v, so the required, the general solution is of the format phi of u comma v equal to 0. So I substitute u is equal to x squared minus y squared and v is equal to y squared minus z squared. So someone now have the doubts in your mind. So can we use the first and the third ratio? Yeah, go for it, no problem. Because the partial differential equation, the difference between the ordinary and the partial differential equation is the partial differential equation, the solution need not be unique. It may have more than one solution. So in this way, I am getting the 1 and 2, u is x squared minus y squared. From 2 and 3, I am getting y squared minus z squared. I need only 2 independent solutions, that's why I can stop it. Suppose if you would like to go for 1 and 3, the ratio 1 and 3, it may generate the another possible solution. That is also the correct idea. Thank you so much.